Now, as we begin the absolute value functions, anytime we're graphing any functions, we have these parent functions or the most basic function. So the most basic absolute value function is y equals the absolute value of x. And we know that the absolute value functions are usually or always going to be a V shape. And we know when we graph these, of course, if we are going to, let's see here, we'll just do it the old-fashioned way. If I have an input, so let's see, if I go with a -3, -2, -1, 0, 1, 2, and I'm looking for the absolute value of -3 is 3, absolute value of -2 is 2, the absolute value of -1 is 1, the absolute value of 0 is 0, absolute value of 1 is 1, and we start to see from here, we start to see the symmetry start to form. So the absolute value of 2 is 2. So as I plot my ordered pairs, I have an xy values, and it looks like let's see. Of course, I have 0, 0. I have -1, 1, -2, 2, -3, 3, and so forth here. And this is all I have, but I do know that I continue, I do know that my equation will continue in a straight line. So as I graph this, I go ahead and connect all my points. Not perfect, but I think we see what's going on here, and this is my y equals the absolute value of x. And here we're going to go with, and when we look at the absolute value function, we know here that, of course, here are how these are transformations and translations of my functions, where we know that A stretches or compresses a function. I know that H moves a function left or right, opposite of the sign, and then we know that K moves my functions up or down, affecting my y-intercept. So if we look at this function, y equals the absolute value of x plus 3, we want to know how did that change? What was the translation to the parent function? And what we know then is my y-intercept has gone from 0 to 3. And we know then that we have a function that will continue. This is y equals x plus 3. And of course, if we were to create the table, we would get those same coordinates out. And let's see here. So looking at our transformations, so we know that when a is greater than 1, we are going to be stretching. We are stretching our functions, and then when a is between 0 and 1, we are going to be compressing a function. And of course, we know that my h value here, when h is going to go from left or right, that's going to be my horizontal transformation, and it's going to be opposite of the sign. So, and then we talked about our k, and our k is going to move my function up or down. So if I have a function, my parent function here can be rewritten a little bit easier of y equals 1 absolute value x minus h plus k. Okay, so, and looking at that here, if we, if we have y equals this origin of 1 absolute value of x minus 0 plus 0. Now that is what I've just expanded out my parent function to see that my horizontal shift is 0. My vertical shift is 0. So if I take and I have a new function of y equals the absolute value of x minus 2 plus 1. Well, I know that my horizontal shift, I moved 2 positive. So my origin went from 0, 0 to 2, and then my x value went to 2, and then my y value, I know I've gone up 1, so my new origin is going to be 2, 1, and then alright, so if I know, goodness, I know that the shape is going to be, I know the shape of my quadratic equation, if my new origin is going to be a slope of, in this case, -1 and a +1. So my new function there I can graph without actually plotting a table, just because I know the characteristics of a absolute value function.